Okay. Hello, everyone, and welcome to Handmade Hero. We are on day 39 here. This is, of course, a full game and engine coded live on Twitch in C and C++, using no libraries, no engines. We are basically doing absolutely everything from scratch, largely sort of as both an educational process and just for fun. I think it's really good for, on both ends, really. For the type of person who actually enjoys programming, then being able to program everything yourself is kind of a fun thing to do, especially nowadays when you don't get to do that all that often. And I've certainly been having fun doing it, and I think a lot of other people out there have been too. And also, it's a great thing for educational purposes because a lot of people just don't have a chance a lot of times, depending on sort of what their programming lineage was, to go through and do all kinds of interesting low-level stuff and build an entire game engine from the ground up and that sort of thing. And so there's just a lot of cool stuff you can learn in there, I think, anyway. I always feel like all the most interesting stuff that I've ever learned in programming came from having to tackle, hard, low-level problems, really, honestly. Even the good high-level programming stuff that I know is largely from having to do sort of, having to think about hard constraints and that sort of stuff. So anyway, right now we are at the point where we've sort of gotten, we're sort of wrapping up the stuff that we can reasonably do before we learn some math, basically, is what I guess how I would say it. We've wrapped up sort of the basic stuff of putting sprites on the screen, loading bitmaps, doing some basic alpha blending techniques, building a tile map and moving around through the tile map, that sort of stuff. But in order to start moving forwards on the engine further, what we kind of need to do is we're probably going to need to start doing some math very soon. So I think today what we're probably going to do is we're going to go through and we're just going to kind of like do a pass over the stuff that we've got so far and just kind of like clean things up and sort of get things into a place where we're relatively happy with them so that we can start clearing the way for doing really maybe starting to have a serious discussion about game math and what sort of math we need to know and what all the different types of math are that tend to come up in games. And so then start to go through some of the most basic ones that we will need in order to move forward, which are basic 2D vector math and stuff like that, which we're going to need for just about everything that we're going to do. So if you went to handmadehero.org and pre-ordered the game using the little pre-order button, you should have gotten an email with a link that allows you to download the source code and the test assets that we use as well. There's 2 zips up there. Make sure you grab both of those. And inside the source code zip, there's a bunch of different zips with source codes from every different day. We're on day 39 right now, so if you want to follow along at home, unzip day 38's source code. Day 38 source code is what we are starting with now. And if you unzip that, you will be at the exact location that I am starting with today. So you could follow along exactly the way that we're, with exactly what we're doing. So if you guys remember, we'd gotten to the point at the end of last stream where we were able to blit basically things on top of other things, which allows us essentially to compose whatever we want in terms of graphics now. We can layer sprites on top of each other all day long. But we had only just finished that, so we didn't really do anything with it. So I was thinking maybe today what we could do is just load in our little hero sprite, and he's in 3 pieces, as I think I showed when I was going through the different sprites that were in there. He's in 3 different pieces, so maybe we'll go in and load his 3 different pieces, and we also have 4 facing directions for him, so maybe we'll load in all of those, and we'll sort of make a thing where he can, as we move, he faces the direction that we're moving or something like that. Just something basic to sort of clean up the bitmap loading and the bitmap display code into something that we're relatively comfortable with for the moment before we kind of move on to trying to do a little bit more serious stuff again, and where we'd have to start talking about math for reals with a Z. So, okay. Assuming that we're in that situation, right now we are loading all of our bitmaps. We haven't talked really very much about asset management in terms of how we're managing loading stuff in the code, and that's actually deliberate. It's not something that I think is really worth discussing at the moment. I think that's going to be something that comes into play once we have a bit of the renderer, sort of the real renderer, once we kind of have more of a real renderer written, is really more the appropriate time to start thinking about that. So right now we just have the most basic thing you might do in a game, which is loading all the assets at startup. Not a particularly useful thing to do if you're actually talking about a shipping game, because like I said, in this game we're going to be streaming our assets in, so loading everything at startup isn't really an option for us, but while we're just developing things, it's certainly fine. So I'm going to have to load these different hero things for 4 different directions, so I'm just going to go ahead and make life a little easier on myself for now and just say that we have sort of a hero bitmaps structure, and that will have basically the different pieces, the head, the cape, and the torso, each for the different facing directions of the hero, so that I can basically say, all right, we have hero bitmaps, and the hero bitmaps that we have are for the 4 facing directions. So we'll just say hero bitmaps, and I guess I'll do, I don't know, we could do something like just a brackets 4, I guess, because we will essentially have to map into that somehow. We'll think about that in a second. But anyway, if I want to load those in, I've already got code that loads each of the test pieces in here into the hero head. I don't know what happened to our hero torso code. I must have accidentally hit Control K. That's a mistake. So basically, we already have code that does that, which is this code right here. But I need to load one of those for each of the facing directions, like test hero front, the sort of the front, back, side, and all that sort of stuff. So I'm going to go ahead and do the stupidest possible thing here. Just do hero bitmaps, and I'm going to substitute in basically one of these like that for each of these ones that we load, like so. And then I'm just going to go ahead and call that 4 times. Nothing particularly exciting here. And like I said, we'll think harder about how we want to do this stuff once we actually think about asset loading and how we want to identify bitmaps, because in general, you don't want to have huge tables of strings in your code. At least I don't. And so that's not something that I would encourage you to do when you're actually doing the real code, but for now it's exactly the right thing to do, because you do not want to be thinking about that while you're trying to work on other pieces of the code. So here is the set of files that we have. We have front, back, left, and right. I'm not sure what the best way to map those to 0, 1, 2, and 3 are at the moment. So I guess maybe what I will say is let's go ahead and we'll just do maybe start with moving right in that 0 slot. And then, I'll basically do it almost like it was a circle. So then there's there's up is after that, like so. And then this would be left, right? And I guess it's not up. It's actually that's looking at his back, right? Like so. And then front is down here, which we've already got. And so that'll load all those bitmaps into memory for us, and it'll just go ahead and be using those for the entire run of the game at the moment. If I go ahead and compile, then we will not be able to find that when we do the hero head, but we should be able to do hero bitmap 0.head, and now we should basically be back to exactly where we were before, only now he's, the other facing direction, right? But I'm gonna need actually to draw, well, you know what? I don't know why I keep forgetting the fact that I can always leave the code running. We don't actually have to. I don't have to, I guess it's just from a lot of the stuff that I work on day to day doesn't have this feature necessarily, so you kind of get in the habit, unfortunately. Oops, that's not right. So if I have the head, I have the torso, and I have the cape, I guess the cape comes over the torso. Basically what I want to do is I want to draw these in reverse order, because remember, this is a lot like Photoshop. Things get layered on top of each other. So what I actually want is I want the torso first, since that's the thing that's the lowest down in terms of what gets shown. Then the cape gets layered on top of that, then the head on top of that. And in theory, that should reconstruct my hero, if I'm not very much mistaken. And yes, there he is. There's the little hero fellow, and he is facing in the direction to the right, which is what I expected. Now, I probably could also say here, if I had a facing direction for the little fellow, right? If I had facing direction equals 0, let's say, and I went in here and said, facing direction like this or something, then I would be able to also sort of flip him around, I suppose, as I go, right? If I flip it to 1, there he goes. 2, now he's facing that way. 3, now he's facing towards us. And so if I wanted him to basically face the direction that he's actually moving in, 3,000, okay? Don't think 3,000 is a very good thing to type in there. If I wanted him to face the direction he's moving, I just need some way of specifying what it was, whatever that last direction was, that's the direction in which he moved, right? So if I go in here and I just say, all right, that facing direction, hero facing direction is now a parameter, and then out here I can go ahead and grab out the hero bitmaps thing that is appropriate based on that facing direction, right? I can go ahead and do, game state hero bitmaps for game state hero facing direction, that would give me back that bitmap that I actually want, the whichever one it's actually supposed to be. And so then if I go in here and just go ahead and change these all to sort of operate off of that, then I've sort of made it so that we can easily store in the game state structure what it actually is we want the hero facing direction to be. So if I go ahead and go over to the code where we actually move the guy around, right, with move up, move down, move left, and move right, it'd be pretty trivial for me to sort of go and just set it to whichever key down you pressed last, which is a totally reasonable thing to do for now. Since we don't really, again, we haven't done that vector math, so we can't really do much. We haven't really written any real hero movement code yet. And so it's not really going to be something that we can do anything fancy with yet. But for now, we can certainly set the hero facing direction to whichever thing you actually pushed down last. So if the hero, was moving upward, we can set it to that moving up direction. If the hero was moving downward, we can set it to that moving down, the left and the right, like so. And then if I go ahead and compile that, these are supposed to be address of the bitmap there. Now I should have a way to basically have my dude change direction. Oops, and I mistyped it once there, so I've inverted my my two directions. What did I do? Let's see here. So if we're moving left, yes, left is supposed to be 2, right is supposed to be 0. That's what I said when I made it, but I didn't actually do it. And so now the hero actually does change for whatever direction he moves in. And I'd like to go ahead and center him on his rectangle as well. You'll notice that basically the bitmap right now, we do have something, in fact, this is probably something worth talking about because we haven't really addressed it. And in the art assets yet, we're not actually at the level of loading art assets where this sort of stuff comes into play, but we'll need to do something as sort of a temporary fix to it. If you consider the fact, if you consider what these bitmaps actually are, right? If we actually go, and you can see we're drawing the player's bitmaps, right? All those 3 bitmaps. We're drawing them with this upper left corner here. This is the point, the position that we're passing when we say we want to draw those bitmaps. There's a bunch of information there's a bunch of sort of assumed information that's all getting baked in there. And it's why, for example, the hero is kind of nowhere near where our rectangle thinks he should be. This was our little test rectangle that said where we thought the hero should be. So it's not at all correct, right? We'd expect the hero to kind of be standing up, with his feet roughly where the bottom of the rectangle was, for example, but that's not at all what's happening. And so considering that situation, right, what's going on there? Well, if you look at what we've got in terms of assets, if you go into the test directory and look at what these assets are, let's say we open one of them up. Well, actually, I'll open up all 3 for a given facing direction. We'll open up the front-facing ones for now inside GIMP. And what you can actually see if you take a look at these guys, in fact, you know what I can do too? That was probably the wrong way to do it. Of course, that opens 3 different copies of GIMP there for me. Thank you so much, GIMP. What I'll actually do is I'll go ahead and we have the front torso loaded. I'm going to load the head and the cape. And so now they're all in there as a layer, right? They're all in as layers. And what you can see is basically the way the art comes in, because these are raw art assets that we're loading, we haven't processed them or done anything to them. Basically, they're just a giant empty space around the guy, which is totally fine. Like, we want that. That's what you want your artist to give you. But then you need to do work to kind of process those down into final art assets that you would use, and you wouldn't store all that empty space, obviously, and so on and so forth. But the other important part of this is that there's essentially an implicit hotspot defined here. Oftentimes it's oftentimes called a hotspot on, that's like the old school term for it. It's sort of what used to call like cursor locations and stuff that you'd use for offsets. I don't actually know why the term is what it is, but there's an implicit sort of alignment point you could think of, which is basically right down here where the dude is standing is where we kind of want to position him in the world, right? We want to have this point align with where we think the player's position is, like something like that, right? Basically, right where he would be sort of standing, where he would be touching the ground, right? And we don't actually have that information yet. And so what we're going to have to do in our eventual real art files is we will have to have those registration marks basically in there, or we'll have to set them manually, one or the other, doesn't matter, but you have to do something along those lines. And so if I look in there, I can actually see down in the bottom here, right here, GIMP will tell me what those pixel coordinates are, like 72, 182, 72, 182, right? You can kind of see as I move, those are the X and Y positions. So we can go ahead and put that in there. We can say that it's 72, roughly 72, 182 for that particular facing direction, right? And that's the one where he's facing the front. So in the one where he's facing the front, and in fact, I guess we could sort of do it here. So it's 72 and 182 for the X and the Y. We could go ahead and make this a little more concise here and basically say, well, okay, there's these hero bitmaps, and we're going to introduce another thing, which is basically the align X and align Y, right, for this bitmap set, so that we kind of know how to position them relative to the points that we actually care about in the world, if that makes sense. Okay. So what we want to do is we want to basically have those registrations that we'll just hard code for now into this part ourselves. And then when we get to the point where we actually are talking about putting large numbers of assets into the game, what we'll need to do is we'll need to have a way of actually loading that data from somewhere. Like that data will have to be produced in a more efficient fashion. We probably don't want to sit here and hand code it ourselves. What we'd rather have is some way of just marking it in Photoshop or whatever it is. And then when those art assets get exported, we'll make sure they get exported to something that we can read when we process our art assets. So I am going to go ahead here and just do something like this, where we can sort of have a nice, yeah, something like that. In fact, I guess what I could do, yeah, this is actually pretty easy. You could actually do this, and then I'll just do bitmap arrowhead equals debug load, like so, and bitmap arrow cape. So just clean things up a little bit here, so there's not quite so verbose. There we go. And now I'll also do bitmap align X equals something and bitmap align Y equals something, and then I'll move on to the next bitmap, right? So this will just load our hero bitmaps as they were. So I'm just going to go ahead and make that change everywhere. I think I can probably, I don't know. You know it's always dicey when I do this, but we're going to do it anyway, I think. I think it's the right time to do it, people. And you know when it's the right time to do it. You know. And when it's the right time, you kind of just got to go with it. You kind of got to go with the flow sometimes. So there we go with that. And then we'll put that here. So let's go ahead and get that going on. There we go. Just clean that up. And now we've got something a little more respectable in terms of code we can use. Okay. So I'm going to go ahead and just manually, for now, do those offsets. But again, that's just something, something definitely to pay attention to. If you didn't have me sitting here telling you the sorts of things that we'll probably do, because I've done stuff like this before, this would basically be a place where you'd want to think in your head, I don't want to be sitting here manually opening up these bitmaps every time the artist changes something, looking to see where that alignment point is. Like, you can see that that's going to be something that's going to take time, and you might, or you kind of want to think to yourself, what might we be able to do that could sort of speed that process up, right? Like, how could we make a better way of setting these alignment points, right? And there's a lot of different ways you could do it, but it's just something to be aware of. You kind of it raises that little red flag where you kind of got to think to yourself, what's the end scheme here? So it looks actually like these are roughly the same. I don't know. Yangxian may have already just kind of lined everything up for us, which is kind of nice. So it looks like they may all be roughly the same. So we won't have to really do... Yeah, I think she might have. Although that one's a little different than the other ones probably. But we could probably use them all at the moment as being 72, 182. That's what actually they almost all look like, is roughly that value. So we'll leave it like that, but we can tweak them later. Okay, so now we've got these loaded. There we go. What? Why are you... Oh, whoops. That's no good. I didn't even realize I still had the game loading. My bad. Sorry, guys. Okay. So now we've got our little fellow there. And what I want to do is, like I said, I've got the information in there now where I could go ahead and correct for where he should be relative to that, relative to the alignment point. And so what I need to do is I need to have some way of actually taking that alignment into account. So in here where I do this draw bitmap, I want to basically be able to change the player left and the player top based on that alignment amount. And so what I'm going to do is I'm going to introduce probably a new function here, which is a draw bitmap align function. Or there's a different thing I could do, which is I could make these basically be some kind of registered coordinates. It's a little bit hard to say at the moment. I think possibly in the interest of... it's so tough to say sometimes, you know? I'm not sure how we want to do this yet. So I think temporarily what I might do is I might just pass these as optional parameters into this thing. We're going to want to do something fancier than this later, but I think we might just want to have it in there right there for now, and we'll sort of, when we have more of a renderer, there's going to be more clearer places where those should go, in my opinion. So I think for now we'll just leave it like that, and we can go ahead and say that the hero bitmaps align X and the hero bitmaps align Y can go ahead and get passed in there. All right. So I'll go ahead and compile that. And what I want to do now, right, is I want to actually use those alignment points to offset the place where we would be drawing the guy. And I think I actually have to, I'm trying to remember what we actually did for player. We're passing player left and player top, but that's not what we actually want anymore. We actually just want the player's actual location, right? So we actually want to know where the player actually is. We want a player ground point, basically, and we want that ground point in X and Y. And so we don't really, we're not so interested necessarily in these sort of like adjustments for the player's height and the player's width and so on, right? That's not actually what we want to see. What we want to see here is we want to see, let's see, something more like that. So that's going to be the player ground point X and the player ground point Y. And then I'll go ahead and keep computing the location for our rectangle as well. You might as well leave that drawing. But then in here, so what I want to do is I want to pass those points that we're aligning to, right? So I'm going to pass those instead of the left and top. So player ground point Y. There we go. So now we're passing the right things in, and now that should make our guy appear even more off-center because we're now passing this point right here, which means it's drawing like this. So now what we have to do is do that alignment to get him back up to the right place. So if I go into that draw bitmap call, you can sort of see it's not going to be particularly difficult. We've got our real X and our real Y that come in here. Basically all we have to do is subtract from those the values that we have for our alignment, right? All we need to do is say, we want this align X and this align Y to actually be sort of the alignment point versus the point that we've been passed in. So if you think about what happens, I'll go ahead and draw it out for you here on our handy dandy whiteboard. I don't know why Krita still is passing a hand for our cursor. Nobody really knows. We don't try to understand Krita, we just accept the fact that it does what it does. And so what I'm doing here, right, is we've got a blit routine, and the blit routine is going to draw a rectangle from like an upper corner. It's going to copy these rows in here, right? But what we have is we have a registration mark, right, in the world that's basically where the player ground point is. So this is the ground point, right? And then we have a bitmap that also has a registration mark in it, right, that's measured from that upper corner. So what we want to do, if we are saying that these two registration marks should line up, then where, relative to the ground point, where would we draw, right, this bitmap? Well, the answer is we just invert, right, whatever this was. If we're saying that the align X and align Y is how you get from the upper corner to the alignment point, then getting back to the upper corner is just going to be a matter of subtracting them, right? And so that's all I'm going to actually do here, is I'm just going to go ahead and subtract those align X and align Y points so that I can offset my bitmap by the amount that would be necessary to move those alignment points into coinciding, right? And so now you can see our little hero fellow He actually is properly aligned with where we thought he should be, and that's all good. He's a little off in the direction that I said maybe he would be off in, which is those side ones. I wasn't sure what we should set those alignments to, but he's, for the most part, pretty much fine. And so that's a lot better than what we had in there before. Now, what I'd like to do is I'd like to get back to screen-based stuff here. You know, we had our tile map, and then we started doing scrolling just as a test thing. I'd like to get back to having things fixed on the screen, where we just walk and we walk around the screen instead of the screen scrolling around us. So I'd like to go back and change things back to going that way for a while until just because that's sort of the way the game will mostly be played, and we don't kind of want this random stuff in here for now because we're going to start working with the player's actual movement code. All right, so hopefully that was all very straightforward, nothing particularly unusual going on there. Let's see, we got about 30 minutes left, which is quite some time. Okay. So what I want to do now is kind of figure out some way to keep our camera centered so that we can have our tile maps back. Also, I feel like we can probably at this point stop drawing the crazy backdrop for now. Well, I mean, we could keep drawing that backdrop, I guess. We could do a number of things. I'd have to think about exactly what we should be doing. It's a little bit difficult to say because, again, trying to manage stuff at this stage in the game, we're kind of thinking about all the different places we could go. There's so much, there are so many different places that we can go, obviously, exploring, because we have every part of the system is still pretty much up in the air. But basically, I guess what I'd say is, do we want to leave that drawing the backdrop in there? You know, maybe we do. At the very least, what I'd like to do is just leave the sort of the world fixed for now. Yeah, so what I'd like to do is I'd like to change it so that instead of drawing out from around the player, because you remember this right here drew our tile maps, this was our little debug thing for drawing what was filled in the tile map. I think what I'm going to do is I'm going to change it so that we have both a player P and a camera P, right? So now I have a place where the camera is looking and I have a place where the player is looking. And they're not going to be the same anymore. So now the camera P is basically going to be you know, the place around which we center that tile map rendering. So all the same stuff we were doing here, we're going to do. It's just we're not going to do them from the player P, right? Instead of player P in here, we're going to do it from this perspective of the camera. And so what we were doing, remember, if you remember how we drew this tile map, we were essentially starting with whatever tile the player was on. We were saying that was going to be centered in the very middle of the screen, and then we were just going to walk outwards from there to the 10 tiles on either side, and I'm sorry, 10 pixels up and 10 tiles up and down, so 20 tiles total, and 40 tiles across, so negative 20 to 20, which is more than actually was on the screen. We were kind of overdrawing a little bit. We were going a little bit further out. So what I want to do is just say, okay, we're going to do exactly the same thing, only instead of walking out from the player's position, we're going to walk out from the camera's position. So everywhere that there was a player P in here, right, I'm going to change it to a camera P, right? And so that's how that's going to work. So now when we initialize that player position at the outset of the game, we're going to initialize the camera position to be something logical as well. So we initialize the player position somewhere in here. There it is. So we're going to say that there's also a stage where we initialize the camera position, and that camera position should just be, let's say, on that very first map, that very first tile map down in the corner, that tile chunk. I think we said basically our tile system was going to be roughly something like 17 by 9 or something like that, I think is what we were saying. So I'll do 17 divided by 2 and 9 divided by 2 for what that was going to be. Game state. Camera P, abs tile y equals 9 divided by 2. And you know what? It's interesting. Well, I guess that's fine. So there we go. And we will go ahead and run that now and see where we get. So essentially, oh, right. And now we actually have to do the work for doing player position as well. But now our camera is going to be fixed. And remember, we were cheating before. We never actually computed where to draw the player. We just drew him at the middle of the screen. So now we actually have to compute where he is, which means we're going to have to do a relative computation to see where is the player relative to the camera. because we know the camera is at the screen center X and screen center Y. We know that's where the camera is essentially going to be in sort of the space when we draw the screen, because that's the definition of the center of the screen, is wherever the camera is telling us to look. So what we need to do is we need to add something to that, right? We need to say, where is the player relative to the camera so that we know where to draw him relative to the center of the screen, right? And so what we need to do is we need to have essentially a subtraction operator, and this kind of leads nicely into that math stuff that I was talking about, so this is going to be good because we'll have it sort of is a nice segue, if you will, for talking about this tomorrow or Monday, whenever we decide to transition over to it. But we've got these tile map positions, and basically what we want to be able to do is we want to be able to subtract, right? We want to be able to say, how do I get from one to another? If I have the player and I have the camera, how would I get from the camera to the player? Because that's the distance that I want to give in sort of, that's what I want to add to the screen center to know where the player is. Right? So what I'm going to do is I'm just going to say, okay, let's actually pretend we have that. Let's actually just say that we had something that could do a subtraction, right? And it could subtract a tile map position from another tile map position, and will give us back the real 32 answer, right? So I'm just throwing in a name for that at the moment. I'm not suggesting this is actually going to be the name eventually, but that, let's do that subtraction, right? Well, that subtraction is just going to be between the player P, right, and the camera P. Oops, game state, camera P, like so. Now, of course, we might as well just we don't really want to have multiple functions for this, so we might as well just do one that will actually give us back the whole answer. And again, this is kind of setting up the math, so we're going to have to kind of do this in a bit of a janky way for now because we haven't introduced vectors yet. So we're just going to kind of see it, and then when we do our vectors, which I guess will be maybe tomorrow, since it seems like this is kind of the most pressing concern, we can kind of see how it cleans this stuff up nicely. So I could basically say there's a tile map difference function, let's say, and that's going to basically give us back the difference in X, Y, and Z when we do that subtraction. So if I do the subtraction, I could do it like this. I could say that we get back a tile map difference, right? And that difference is going to be the difference between the player and the camera. Once I have that difference, it's pretty easy for me to go ahead and add it in. So I basically now would have a way of getting to where I think the player actually is. So all I need to do is make something that could subtract these two and produce one of those as a result. So if I look at what has to happen to do that, right? Well, part of it is really, really simple, right? If I've got two of these, let me go ahead and set this up for a little more success here. If I had a tile, there we go, like so. So we've got a tile map difference that we want to return, right? And we want to basically compute a dx, a dy, and a dz out of that. Now, what I'd like to do is I'd like to take in two tile map positions, an A and a B, like so. And then I would like to say, how do I subtract the two of these? Well, I know how to subtract the offsets directly, because the offsets just are real 32. So producing another floating point offset by taking the difference of these two is really, really easy. It would look like this, right? That's all I would have to do. I would literally just subtract these offsets. But what I need to do now is I need to account for these abs tiles, right? I don't have a way of accounting for the abs tiles at all. Okay, so in order to do that, I want to be able to do a signed distance of some kind here. So what I may do is say, all right, we could do the subtraction in float for now. I have to think about how I actually want to do this eventually. But for now, we could basically say, all right, we've got the signed distance, which is the d tile distance, right? And that's going to be, the abs tile x from A minus the abs tile y, like so on, like so. There we go. So I'm going to do that subtraction to get these deltas here, d tile x, d tile y, d tile z, right? And then those are in tiles, so in order to change the distance in tiles, I would need to know that tile side in meters, right, I need to know that tile map information. So I'm going to have to take the tile map in order to do that conversion, right? I need to know for every one change when I do this, how far are they in tiles? I need to know how far that's actually going to be in the real meters units that we're using for everything else. So the tile side in meters, right? That I'm going to have to go ahead and multiply in here in order to, and I guess I could do that down here as well. There we go. So basically I have my d tile x and d tile y, tile map, side meters, d tile y, like so, and tile side in meters. We don't really know yet what our z should really be in this case. It's unclear that we ever want to actually have a dz in this way, but I'll put a to do in there to think about what we want to do about z, because z is really kind of not a real dimension in our system, because since the way tile map games work, you don't really have z in the same way that you have x and y, so it's hard to say. But anyway, after we compute these tile differences, and then we actually go ahead and do the math here to add in the tile difference amount plus the offset amount, now we've got a real dx, dy, and dz. But of course, this is actually all going to be in meters, but we need our meters to pixels in order to actually turn that into pixels on the screen, and these are all in pixels from here. This is all renderer units. So there's our meters to pixels that gets added in there to convert that difference that we did. And of course we have to pass the tile map as well, which I think is just game state tile map. Okay, so there we go. And so I believe that is roughly all we need to do to get that guy going. And of course, I got to return the result, of course. And so I think that should be roughly correct. And of course it isn't, classically. You gotta love that. I think that's just because I forgot that we have to flip things around for our kind of we don't really have a render yet, like I said, so our coordinate systems are a little ad hoc here. So of course, yes, this is where we have to do our flip always, which, you know, is kind of annoying at the moment, but that will all get handled in our renderer for us. So it's not as janky as it seems like it has to be. The fact that the up and down doesn't quite work the way that we would like it to. But anyway, so yes, what we would like to do here is we'd like to have the player ideally go in the opposite direction. Also, let me see here. We should also make sure that we don't have a bug in our offset x, offset y stuff. I don't think we do, but we could double check to make sure that we don't. So let's go ahead and double check everything here. So we're going to take all of the tile-sided meters, the DTY. Y is always going up. It goes up in tiles as well as in our meters units there. So that's correct. But yes, this is wrong because obviously the guy is supposed to go up, not the coordinates are inverted in the renderer as from what they are in the game. That didn't seem like the bug we were having though, but I don't know. Yeah, see, we still get a little, yeah, I was gonna say, that was one bug that we had, but I'm like, there's that weird kind of, we get that kind of nasty thing where the X is related to the Y. I must have had a typo in that code. Let me go back and look at it for a second. Oh, fantastic, yes, I have tons of typos. Wow, those are amazing. Yeah, there we go. All right. So I think we are good to go now. Our dude is moving around, and the camera is where it is supposed to be, but we have a few other things that we would need to handle in order to get everything working properly. Also, I should note that we still have not finished our bitmap routine, so if we move to the top, you will notice, I don't know if you can see that, that our guy doesn't actually, he can't clip off the top of the screen. We have a to-do in there about that. So those are the things that we'd have to finish. So let's get him walking throughout the entire map for now. For example, when he comes off the top of the screen here, You'll notice the camera will never change locations because we have never actually programmed the camera to change locations. So he is, and we also are drawing him whether he's on the same Z plane as the camera or not. So when we go upstairs, we'll never actually see that. So we have a bunch of stuff that we need to fix. So let's go ahead and fix all those. We've got about 15 minutes left, just so we can have things cleaned up and working relatively well, so we can start working on our math. Having real math is going to be a pretty nice thing, let me tell you. It's been a bit of a struggle to kind of go through without ever having really vectors or anything like that. But you know, you got to pick an order to do things in, right? And so it's always important to kind of, you know, not go too far too fast. All right. So first things first, we always want to move the camera to wherever the player is in Z, I would say, right? So no matter what happens, I would say the camera P, I'm just going to say that the abs tile Z is always going to be the same as the player state abs tile Z, right? Just so if the player goes up, then the camera goes up. And if the player goes down, it goes down. And so I think, yeah, there you go. So now we can actually get up. And so the only thing that now we have a problem of is that the player moves off the screen, the camera doesn't ever follow him, right? And that's no good. So what we want to do here is we want to then say, all right, the other thing we need to do is to see whether the player ever gets more tiles to the left or to the right than he should be relative to the player. Now, what we could do if we're always locked to screens, there's a lot of different ways we could do this. You know, it depends whether we want to drop down our own manual camera points, and this would allow us to do different things like having screens of different scales sometimes. There's just a ton of stuff we could do here. I'm trying to keep it, again, relatively simple because one thing at a time. But we basically have a problem with our tiles X and tiles Y, where what we want to do is if the player moves one screen to the right or one screen to the left, we want the camera to follow them there, right? And so the simplest way we might do that is just basically say, if we rounded the player's position to whatever the closest screen center point was, we want the camera to always be looking at that, right? And that's one way we could do it. I'm not sure if that's the smartest way to do it or not. Yeah, it's really hard to say. So one way, I mean, you know, let's put in something. Let's put in something even simpler. Let's say we've got this diff function here, right? Like so. Oops. In fact, I guess we don't even really need the diff function now that I think about it. Well, I guess you kind of want it. We probably do want the diff function. I don't know. It's difficult to say. But I guess what we'll do for now is say, all right, when we do the subtraction here, then basically what I'm going to do is say if the delta x is greater than a certain amount, then I'm going to go ahead and move the camera forwards, and if it's less than a certain amount, right, I'm going to move the camera backwards. I'm just going to see how that works out. So basically, how far is it? Well, I'd say it's that 17 by 2 number again, right? If he moves basically more than one screen's worth away, then we'll go ahead and do the change. So I don't know. Let's see what that number actually ends up being. If I have 17 tiles across, is I think what we said it was normally on the thing, and so that's 8.5 is the midpoint. So 8 tiles in. The 8th tile, right? We have 7 tiles on one side, 7 tiles on the other side, and then the middle tile, right? So basically, if you were to get, let's say, 9 tiles away, if you were to get 9 tiles away from the camera on the X direction, that would be too many, and we'd want to flip to the next screen. So what we could do is say, all right, let's take 9.0f is the number times the tile side in meters, right? And that is basically going to tell us tile side in meters. That's going to say that the player moved too far away from the camera, right? I'm just going to go ahead and do that like so. And let's just see what that gets us. Again, we got to go upstairs first because we can't get out of this room. So we go out there, and then we go here, and oh, that is not. Oh, well, that did exactly what I told it to do. we're supposed to move the full 17 tiles, but for some reason I only had it move one tile, which is not really going to help us here, to say the least. All right, let's try that again. My bad. That was not very bright. So yes, if I go out here now, we should see me come back on the other side, which is exactly what happens, and that's all good. Again, we have to go fix our problem so that this doesn't happen. So that's the next thing to do. And then we also have to fix up and down. So here we go. I can walk out here, and then I can kind of walk up here. And this is the place where we would like to go off the screen. So again, hey man, since we got live code editing, I don't have to walk all the way back there. I can just go ahead and say, let's duplicate this. And so since it's 9 in the direction, I guess that would mean it was 4 here is the tile-sided meters. And so the dy is going to basically do this, right? And that should give us some better motion up and down as well, right? So when we walk off the end there, oh, okay, so it's actually, sorry, it's not 4, it's 5. I don't know if you saw what was happening there, but we were right. It's because we didn't encompass that extra tile. When we walked onto that tile, we were in neither camera's space. The camera constantly would flip back and forth going, oh, I'm too far away. Oh, I'm too far away. Oh, I'm too far away. So you actually have to do, all the way to the end of that 5th tile, or at least to the middle of it, in order to not have that sort of problem. All right, so I believe we can now walk all around the world with our guy, which is nice. It's always good. He's kind of a happy little fellow. Well, he's determined. You know, he's happy, but he's determined. You know, that's how he is. So anyway, he's going to go out there. Let's go up there. Let's see here. Go through here. Yeah. So everything's nice and happy. Everything's good. No complaints. All right. So basically, all we really need to do now to get ourselves back to a place that's pretty stable for him walking around and where we can start to talk about wanting his movement code to be better is you know. I'm walking out there and I'm clipping against the screen here. We just need to make sure that we do the math right for clipping off that edge of the screen. I think we already do the math right for clipping off the other edge of the screen, meaning that if I was going to go down, I think that works properly. Like so, for example, going off the screen this way just works, right? So that's all fine, but it's that coming in off the min that we haven't done yet. So let's go ahead and do that, and draw bitmap. Let's go ahead and make sure that this function now properly handles that. You notice the to-do here that we left in there, which is source row needs to be changed based on clipping, and so that's the problem. So basically what happens is our rectangle that we're blitting does properly get clipped, so we don't overwrite memory or do anything bad like that, but what we're not doing is advancing the source row and basically that starting pointer for where we're copying the pixels. We need to advance that by however much we clipped the left and top edges of this bitmap. So basically this part right here, when we do this, we need to basically save an offset value. We need to save like a source offset X, and we need to save a source offset Y to tell us why we should be fetching pixels further in because we aren't drawing the ones that are off the screen, right? And to make that a little clearer for folks who haven't done this sort of thing before, when we're normally drawing, right, what's happening is if we're clipping off the other side of the screen, we don't have to adjust the point where we copy from, right? All we do is copy less. So when we copy a row, if we started here, all we have to know is we'll stop copying before you would have otherwise, which would be all the way out here. But if we were to clip off the min edges of the screen, right, in a case like this where we're clipping off both of the minimum edges, then we can't start copying from here. We actually need to start copying from here. And so we weren't doing that, and so obviously we were going to have those graphical glitches because what was going to happen is we were going to start copying from here, but we were going to draw it to here, which basically gives a phantom translation of our bitmap down and to the right, and it makes it look like it stops early because this is still the clipping for it. So it basically translated our guy this way and clipped him, so you'd see like his head like there, when his head should be up here off screen and his body should be here, right? So all we need to do is just advance that pointer, pre-advance that pointer to the right location, and that will totally fix the bug that we have. So all we need to do here is basically go, all right, we have this, which is our source row. but we could go ahead right now and update it to say that whatever our offset x is, we'll move that many pixels in, and whatever our offset y is, we'll multiply that by the bitmap width, right? And that will offset it by that number of rows. So that way we'll get the row offset and the column offset. We're all good there. So all we need to do now is actually store them, and of course it's whatever it was, whatever this value was, that this negative value is we want to offset by the opposite of that, right? So there we go. And now we should be copying this guy, or we'll just go ahead and just straight up fucking crash, because it's amateur programming hour here on Handmade Hero, apparently. I don't know exactly what I did there. Because I forgot that this bitmap is bottom up, right? So basically we have to actually go down. We have to actually subtract for each of the source offsets. Yeah, not the brightest move by Casey, it's true. But again, a lot of this stuff is just, since this is test code, you can't expect me to remember all that stuff. When we actually are doing the full render code, a lot of this will be more commented and more directly. We'll have boiled it down more, and then you can get mad at me. So I'm not going to owl to shame that. That was not an owl to shame moment. In my opinion, I'm going to give myself a bye on that one. All right. So anyway, I think our dude is pretty much okay now. You can see how he clips properly now off either edge of the screen. So that's all good. We'll try it on up as well, just to make sure that, yep, that's all good. Up and down seem to be good there. No issues. Yep. Everything is fine. Okay, so he can go adventure around our very sparse and not particularly interesting world, but at least everything is working the way that we think that it should. And so that's good. That's all very nice and good. The other thing that we probably should do at some point here is check our frame rate, because of course, at the current moment, we're doing this rendering code without any optimizations. It's not SIMD. It's not optimized at all. It's crazy. And so we should probably verify that all of this crazy stuff that we did without any thought to the performance of it whatsoever. And we're also not even using GPU. So we're at a severe disadvantage performance-wise here. So we should actually just go and check, because we still haven't had a chance to do anything in terms of a heads-up display for ourselves. I just want to take a quick second to look to see what our frame rate actually is in practice. So let's take a look at that. And it looks like we're still okay. We are hitting that 30 frames per second goal, and so we are in good shape. All right. Even with all of that pigginess. So I think that's about everything that I wanted to do today. I can't think if there's anything else that I thought that I needed to do. I don't think so. So maybe let's go ahead and go to the Q&A a little bit early. I'm trying to think if there's anything else. Oh, well, you know what? There is one thing we could do that I wanted to mention. I mentioned this in the forums to people because they were having trouble with it, and I just hadn't had time to do it myself. We could just throw it in at the end here. And that is that since we're doing our live code loading, sometimes a problem happens with Microsoft Visual Studio, which is that when the compiler writes out the executable, it sometimes writes the executable first and the PDB second. Well, I think it always actually does that. And so the PDB actually finishes writing after the executable finishes writing. In this case, I should say DLL, because it's the DLL that we actually care about. So when we write that DLL out, and then the PDB gets written out, when our hot loader goes to load the executable in, it will load that executable almost immediately, because remember, we're running at 30 frames a second here, so it's going to load it very, very soon. And the PDB sometimes hasn't finished writing. So what will happen is Visual Studio will fail to load the PDB, and then we can't set our breakpoints and stuff, right? Because the PDB is still open for writing. So what I wanted to do is to show a little trick that we can do here to avoid that problem. People were having trouble with this on the forums, and I told them how to fix it, but I figured people on the stream should know as well. And that's basically just to create a lock file. So all we really have to do is just in the directory where we're going to put that DLL, right? All we really need to do is we just need to put a lock file in there. And so we can say waiting for PDB, and we can put that out to like lock.temp or something. And then when we are done, we'll delete that lock.temp file, right? And that lock.temp file basically just says don't load right now, because whatever you're going to load is going to be stale. And so if we look at what happens if I do that when I'm doing this compile here, it's probably hard to see because you can't actually, we probably can't catch it in time. Well, you know what I could do? I might be able to, oops, I might be able to show it here. I'm not sure if I will not be able to catch it. But essentially, if you think about it this way, where's my build.bat? Handmade, build.bat. I don't know if you can see it show up there at all. Oops, that's not right. Code build.bat. I don't know if you can see it show up there. Probably not. Yeah, it never actually poots forth, does it? Let's see if I can get it to go. There it was, lock.temp. I don't know if you can see that. Pause the stream. But anyway, there's a lock.temp file now that gets created there. And that lock.temp file will not get deleted, hopefully, until after the PDB is loaded, because the compiler will have returned entirely at that time. So once we know that there is that lock file in place, that's just a dummy file that's there to let us know when that thing started and ended, right? What I can do is I can go ahead and just test to see if the lock file is there and assume that whatever compilation has to be going on, no matter how complicated this thing gets, we'll always wait and we won't delete the lock file until all the things that we need to have happen before the hot loading occurs have occurred, right? And so when we do that sort of load game code thing, I don't even remember where that is at this point. It's load game code. What we'll do is we can actually say when we go to load that game code, I think this thing actually sets, let's see here. This thing gets that DLL last write time. So what we could do is when we actually go to load the game code, we could check to make sure that the lock file is not there, right? And we have two places technically we could do that. We could do that really in either position. And I don't know which one we would like to do. It's really hard to say. I think we probably just want to do it here. So I think what we want to do, and why is this still there? I believe we are getting the proper path. I think we're doing both of those to-dos. We need to go check to make sure we don't have a lot of to-dos lying around that don't have to be there. So basically what we could do right here is just go ahead and do the if right here to see whether or not that lock file actually exists. And so I think the easiest way to do that is just to do like maybe a get file attributes or something like that. Let me see what the easiest way is to do that in to see whether that file exists. I think actually 132 file exists. Is it get file attributes? I don't actually know. Path file exists. I don't think that's actually the function that we want. Windows 2000 professional requires jalopy. Yeah, I don't actually know if we want that. That doesn't seem like a good thing. Get file attributes might be the easiest. Get file attributes ex. Let's see about that guy. I could also look. I don't think, is there a file exists function? I don't think there is, but we can double check. File exists, path file exists, copy file, no. So let's go ahead and use get file attributes ex, and basically that should return false if we can't actually get it, right? So we'll literally just call this thing, right? Like so, and if it actually was there, then we'll be good to go, like this. Okay. So what we need to do here is we need to have that file name, whatever that file name actually has to be. And so it's going to be source DLL name, temp DLL name, and lock file name, right? Like that. And so we'll go ahead and pass that lock file name. Now, whenever we do a Win32 load code, we need to do lock full path, and, or I guess we say game code lock full path, like that. Source game code DLL. And so here I should just be able to do temp with lock. There we go. Game code lock full path. And that's, I think, just called it lock.temp. And there we go. So I think that should be sufficient. I'm not sure, but I think it is. And so let's take a look. So if I go in here, well, evidently not. Oh, I did it backwards again. Get file attributes. So it's basically if not. It's supposed to be if we don't see the file, right? It should load. And so I think that should be fine, but let me just test to make sure that we still have our hot loading enabled. So, okay, let's go. Got this guy going. I'll make a new frame, maybe. Oh, the hideous colors. Maybe I won't make a new frame. So I'll just move this guy down here. I guess we could go ahead and do a loop for now. Let's go ahead and make him go up here. Whee! Okay. And so, I don't know. What do we want to do? Let's see if our live code editing, we'll live code edit him to go backwards instead. So I'll go in here to handmade.cpp and go to the facing direction stuff. And basically I'll just say, oh yeah, whenever he's going to the right, let's actually make him face left and vice versa. Yeah, there we go. So should be good. Yeah. Yeah. All right. I'm satisfied. Okay. So I believe we now do need to go back to our originally scheduled program. We're a little bit over now, 3 minutes over. The Q&A. Now that we have taken care of that, I think everything is kosher now with that. Yes, I believe it is. So let us go ahead and go to the Q&A now that we've finished that. If you would like to have me answer a question, please put Q: in front of it so that I will see it. And that starts now. Anything that you've put already that's Q:, I won't see. It's anything that starts now and has a Q: in front of it. I will take a look at. And please try to keep the questions to things that happened on today's stream or previous streams. So please try to save off-topic questions or things about what we're going to do in the future for pre-streams. I try to show up about 15 minutes early to most streams. I can't always make it, but I try to. And I answer off-topic questions at that time. So if you're interested in asking off-topic questions, that's totally fine, but come before the stream to do those. Most of the time I try to be here before them. So yeah. Let's see. Genetic species. Can you do that live code with a function call? That could just be a poke. I'm sorry, I'm not sure what that means. Can you do that live code with a function call? Could you be more specific, perhaps? Let's see. Enumerations. Am I correct to say you've not used them in Handmade Hero yet? I'm guessing this is simply because it's too early to know what will eventually require enumerations and not some other reason. Did we really never use an enum? That may be true. We may never, yeah, so we haven't ever, I do use enums. I'm not avoiding them for any particular reason. We just haven't had like sets of types or anything. Probably when we do like entities, you know, our entity types might be an enumeration or something like that, you know. But yeah, I'm not avoiding them. I guess they just haven't come up yet. Why not layer the individual body parts into a single bitmap? That way you only have to draw one image instead of 3. Well, that's a very good question. And hopefully this is a very good answer for you. I want him to be very bouncy. So I want him to kind of hop along, and I want the 3 parts to kind of do this sort of a thing, right? So I asked Yangshin to make sure that they were separate so that he could kind of be like a little springy guy that springs around. And in addition to like squashing and stretching the bitmaps, I also want them to move relative to each other, if that makes sense, to really kind of give that sense of you know, motion. Are you wearing a blue cape like the Handmade Hero today? No, it's not a cape, it's just a shirt. I don't actually have a cape, a Handmade Hero cape. Let's see. I just wanted to point out that there is a magnifying tool in Windows that came with Arrow. Yes, it's true. Unfortunately, it's really hard to use. At least I find it hard to use. I like this other tool called Zoom In, which I just haven't gotten around to finding. I don't know where it is. I may have to copy it from like an old version of Microsoft Developer Studio or something. But it was so much easier to use than the one that came with than the one that they ship now. Let's see if they've got this. Zoom In. I don't know. This is someone else's stupid Zoom In. I want the actual Zoom In that used to come with the dev tools. So there used to be one in Microsoft Soft SDK tools. Yeah, I'll have to go hunt for it. I'll have to go hunt for it, because that's the one I actually want. I suppose I could use Color Cop. In fact, maybe I should just use Color Cop, because Color Cop's pretty awesome. Yeah. But it looks like it doesn't do real time. Oh well. Yeah, I don't know. I want to go get that zoom in tool because I don't like the one that comes with Arrow, and that's why I haven't been using it. It's too hard to use, in my opinion. Andy's SZ, don't you want to test the debugging? You can't really. We'll just have to see if we no longer hit the problem, because there's no way to tell whether or not we just got lucky. You'd have to test it like lots of times. You can't, right? Because it was only sometimes that MSVC didn't actually do the reload. So I just wanted to test just that much, and then we'll see as we go forwards if we have the problem where it can't set breakpoints. Garlando Bloom. Oh no, I swore? I didn't mean to swear. Oh, that's the second time. Oh my goodness. I don't know even what I said. That's how bad of a swear that was. That's awful. Okay. I'm trying to keep the language okay for kids. And, normally I swear a lot, I will tell you. So it's been rather difficult. Can you add a standard def include to handmade platform.h? Sure. I can do that. In fact, people have been asking for a few things in here. One was to get standard def in there so that platforms could get, some platforms want that for size T, this guy right here. And the other thing people were asking for is they were asking if maybe the utility functions could be moved in there because they were having trouble compiling. Well, in fact, you can kind of see what they are. Basically, we're still using handmade.h in Win32. And so what I could do is I could force it to stop doing that and just do handmade platform.h. And that would tell us what our stuff is that we're missing, right? And so we would need to move in basically all of this stuff for the most part. So we would need to move in to the platform layer all of this code, I think, probably. Let's see here. In there. I don't know what else. And get controller. So get controller would have to be in there as well. Where is get controller? So those are the things that the platform layer was currently calling. And I don't know that I really want all of those in the platform.h at the end of the day. Oops, gotta move that down a little bit. There we go. And so, yeah, I don't know if I want all of those things in there. That may not be the best idea. But at least now we compile clean, so people who are porting to other platforms can go ahead and do that. So hopefully that helps them out a little bit. Just making sure that basically our Win32 layer just only includes handmade platform.h, and that's a little more consistent and make it a little easier for them. Why does the guy have no feet? Well, I mean, if you look, that right there should tell you why he has no feet. How do you know which compiler options, like CLR and standard headers, you want to use? I'm not sure what you mean by that exactly. I mean, essentially, my general rule for standard headers and compilers is that you want to include everything in the platform layer, and you want to include as little as possible in the main code. So you would ideally, I feel like you wouldn't want any includes in the stuff that gets actually included in the game. But the bottom line is that's not actually physically possible most of the time because you need to get a little bit of information. I mean, you could duplicate what was basically happening in these headers, so you could do that. But for the most part, what you're trying to do is minimize the stuff that you're including to only be definitions of stuff that you actually need in terms of types. But you don't want to include anything else for the most part. That's the way I usually like to do it because I like to make sure that all of my code is in my code and that I don't call out into the library for anything so that I know absolutely everything that's going on, and I can guarantee that everything's portable and so on and so forth. But yeah, that's just me. In terms of, in general, how you decide what you want to do, it's whatever you want to use. Like, I mean, if you want to use stuff, I mean, basically, the way to know about size t is just that if you go to any kind of reference on C++ or C, you can kind of see like what you need to include to use it. So for example, in C++, if you're using the standard size t, it tells you here like that's the include that comes with. If you're looking at the C library, I don't know where that would be exactly. I don't know who says where that is. Here you go. They're defining the header file standard def.h. So you kind of have to go hunting for them, or you can search in your C compiler's include directory to try to find where they are. But it can be a little hairy when you're like, I want to use this language feature. Where is it, right? So I don't know. So I don't know if that's exactly what you were asking. If you want to ask more specifically, I can try to answer it maybe perhaps a little bit better. Changing the literal value of a variable is a peek and poke technique, poking a value into a memory address. Oh, I see what you're asking. Okay. Yes, for the live code, it is not poke based for what you're saying. It is full-on live code. So for example, what we were doing there is when, like, for example, you're moving this guy around, we could actually, you know, change the code to do anything we wanted. We could change it to do absolutely anything. So for example, we could just go into the actual code where the guy was being drawn, right, in the draw bitmap code. And we could just full on, you know, draw more heads, right? I mean, if we wanted to, we could just do, you know, anything. And there's a second head on the guy. Maybe we could go in and say we want to draw lots of heads on the guy. Head count or head index equals 0. Head index is less than 10 plus head index. And then, you know, you get into this kind of a situation where you just have so many heads you don't really know. Oops, I didn't mean header. I meant head, like so. Right, and this is still all running, you know, totally fine. And you can do the loop live code editing thing that I was doing before, where the dude kind of does whatever his thing is that he does, and that can be running all the while if you want to, right? And so I can switch up what I'm doing here. I can remove that and just draw one of them, right? Like that. I could do anything I wanted to. So yeah, we've got pretty much as hardcore live code editing as you can get in a reasonable amount of time. I have some harder core stuff where you can actually change data structure, layouts that I've done in the past, but that's a huge thing that would take many hours of explaining on the stream, so I decided not to do that one. But we've basically got as hardcore as you can go without that. So yeah, it's pretty awesome too. We haven't had a lot of chance to use it yet because we're not tuning stuff at this point. Really where this becomes really great, and we'll see this possibly next week or maybe the week after, is when you're trying to tune like the feel of an animation, like in that movement code or whatever. Being able to do this where you can just see him walking around and tune it and tune it and tune it is pretty awesome. So I'm looking forward to that. What will happen if you have an item that is in front in one view but in the back on another? Since it seems you've hard-coded the order in which they're drawn, will you reorder them based on the view or some other rendering technique? So it depends largely. I suspect that the way you're... Okay, so this is just some code that we put in here. I feel like I say this a lot, but I guess it doesn't necessarily often come through. All of this is test code. None of the code that we have written in anything in here will actually get used, right? It's all speccing out our game engine. So we will not be drawing the player anything like this in the shipping version of the game, right? It will literally bear absolutely no resemblance to what's going on here. All of the stuff we are learning and that I'm explaining while we go through it will absolutely be important, because every single last thing that we've learned here will be crucial in our making the engine good. But none of this is how you'd actually do it. So when I say that I'm just drawing a couple things in here so we can put the hero in, that's literally what I mean. What we will actually be doing is we'll actually have a number of ways in which things actually get sorted into the scene, and you'll see that once we actually get to the point where we have a renderer as opposed to just some test code, if that makes sense. Why don't you use the Emacs calc? The reason is actually because I have not bound a key to it yet. I only just figured out that it was there, like accidentally on the basic Emacs. Emacs has so much stuff in it that I only know like 0.5% of the things that are in there. And so I need to remember to bind a key to it eventually so that I can just quickly hit it in calc. So I have to hit meta x quick dash calc, blah, blah, blah. It takes too long. I'm going to bind a key to it at some point. Oh, someone is saying that maybe I can get zoom in at sysinternals.com. Is that true? Miscellaneous utilities. Zoom it. Zoom it is different than zoom in. Interesting. Huh. Well, to be honest with you, though, I'm kind of curious about that. And since I obviously love Mark Rusinovich, I might be inclined to take a look at that guy. I did kind of want zoom in, but zoom it sounds like fun, I will say. So maybe we'll check that out. Yeah. All right. Thank you for mentioning that. Yeah, that could be useful. Let's go ahead and close that down there. When you panned off the min edges, can you explain how the head was redrawing over the body? So redrawing over the body, I'm not sure what you mean by the head was redrawing over the body. Well, I mean, I can sort of just quickly go through what was happening there and hopefully answer the question as part of that. So, and just for the fellow who was asking about how extensive our live code editing was, I will go ahead and introduce a bug in the code while it's live. There we go. All right, so I'm going to turn off the looped live code editing here and go ahead and get us to a point where we could actually see that happening. So this is what was happening, right? You can see that bug now that I've commented out the line. So the head wasn't redrawing over the body. That was not actually what was happening. What's happening is once we hit the minimum edge of the screen, right? So remember, the bitmap is bigger here because there's just a bunch of alpha, empty alpha around that guy. Once we hit the edge of the screen and we keep going forward, what we're essentially doing is we are now clipping the blit rectangle. Like the blit rectangle is like this big, right? And in fact, you know what I could do too, just to show this to you? I could go ahead and write in here the R channel always on, for example. Like I could do something like this, right? But I have to do it just for dudes. Just for the little dude there. How do I want to do that? Well, the way I could do that is say if I was clipped, I suppose. So I could do it this way. If what did I call that variable? Source offset. So if source offset X or source offset Y, draw the red channel. Oops. So what I've done is I've made it so that you can see the entire area of the blit once it starts clipping, when it clips off the minimum edge, right? So hopefully you can see what happens. I move up there and now my rectangle is flush against the side. As I move further over, our rectangle properly clips to the size that it should be. It correctly sets the size of the blit. But it is not changing the offset in the bitmap where it's copying the values from. So it's always copying as if it were going to copy the whole thing, but it just gets clipped out entirely, right? As the rectangle shrinks and shrinks, it's only copying less and less. So what we need to do to fix that problem is we need to copy from further in at the bitmap. As we fall off this edge of the screen, we need to move in on the source, the place we're copying from. We need to move in so that he moves over, even though he's only copying a little bit. So it's copying this, this part from the rightmost edge of the bitmap, basically, you could think about it as doing that, right? And so when that happens, right, go ahead and turn the bug off. Now what's going to happen is, essentially, you can still see it's only blitting this piece, right? It's only blitting that rectangle right there. But what it's doing is it's skipping, when it copies a row, it's skipping the first n pixels, where n is however far off the edge we were, right? And so that allows him to move all the way off, right? So does that make a little more sense? Right? We didn't have to do that when we were clipping on the other side of the screen, because on the other side of the screen, we're going from the left to the right when we copy a row. So all we had to do was stop early. So this for loop that's going to a max x, when we clip the max x, that just works. That just solves the problem right there. We set the max x right here, right? When the max x is greater than the buffer width, so when the max x would be off this edge, we go ahead and stop it, and we set it to that edge. That's all we needed to do, because we just stopped copying the row, right? We just stopped copying the row early. That's it, right? But when we're, trying to move the guy by clicking the keyboard when I'm focused in the other window. But on the other edge, it's not that simple, because if we were to just stop copying the row early, we get what we saw before, where the guy appears to clamp against that edge, because it's still copying the pixels from the beginning of the bitmap, where we don't want to copy those pixels, right? So hopefully that makes more sense. I'll go ahead and remove that there. And there you go. So now we're back to normal. Oops. Can't wait to do better player movement code. It's awful trying to get through these doors. Yeah, I'm just like, every time I try to go through a door, I'm like, I gotta fix that. Do you ever write tests, or does the average game not have unit tests? Well, so unit tests, I've covered this a couple times before. I'll just say quickly again. Unit tests aren't very useful in games because not many things have the kind of well-defined repeatability that you need to make unit testing successful, but sometimes you do. And so for like the renderer, for example, that would probably be a place where we do unit tests. And we will have some performance tests which look a lot like unit tests. They're not really testing correctness as much as they're testing speed. So we'll have some of that. So you will see a little bit of that. You just don't see as much of it as you could in other disciplines where the state space is much simpler. Games have huge state spaces that are very different from the kinds of code that is usefully tested by unit tests. And so usually if you were doing unit tests on a game, you're often testing things that aren't really the hard part. So you're bulletproofing your easy cases by writing unit tests in most game code, and that doesn't really help you. But there are places where you can use it, and we will use it, I suspect, on the stream in a couple places. We just haven't gotten anything. We're still doing exploratory work on how we want the engine designed, and so until we get to some code that we think that we're going to ship, there's really not much point in doing unit tests, right? Because you're just kind of wasting your time. You're wasting your time bulletproofing something that you aren't planning to ship. Does this form of live coding work with adding member variables to structs? In some cases, yes. In some cases, no. Like I said, there's the harder data layout stuff is something we didn't do because it was going to be a much more involved process to do that. It involves writing metacode and stuff, and so I didn't want to do that. But you can add to like the end of structs in certain situations, but you can't rearrange data members. And the reason for that is because, you could as long as there weren't any of them in use yet, right? But assuming that there are ones in use, they won't get remapped. And so what you need to do is you need to go in and remap all of the ones that were different now. And so we didn't implement that. How does this test code help with the future architecture since it all gets dumped? So basically what it does is it will define exactly what we want our engine to do. I always say write the usage code first, and I really, really, really mean that. Never write an engine without knowing exactly how the game is going to use that engine, and that is what we're doing right now. So we're basically just building a game, doing whatever it is that we want to do first, and then what we'll do is we'll just kind of pull out those pieces and turn them into real engine components as we go. And we already did a little bit of that with our tile map. We haven't done a whole lot, but we've already made the tile map stuff work kind of that way, where we've defined what it needed to do, and we haven't gone and done like full hardcore engine stuff on it yet, but we did pull it out into a little system. And so that's the way things will work. So don't think of it as dumping, think of it as continually evolving. But the point that I'm trying to make before was that none of the code that we wrote as written will be what ships in the game. So you don't really have to worry about it at that level. You just have to look at it and go, okay, what does this do right now, and why do we want it to do that, and what do we need the engine to eventually do for us in that case? So the question that the person asked about sorting is actually totally fine to ask a little further down the road when we're trying to figure out how we want to do things attached to guys so that they sort right, and all those sorts of things. But, you know, that's not really where we're at this point. We're not really trying to solve those kind of problems right now. Once we get to them, we'll think about how we want them solved, we'll spec that for the engine, push it aside, and off we go. I'm not sure if this is true. I'm assuming you are making the guy clip when leaving the screen. But why make it clip if you can just make it follow the yellow box, which might clip the guy itself? Again, I really... sorry, I'm not sure I understand the question. Yeah, I apologize. I'm not sure I understand the question, so I can't really add much to that. If streaming assets will be required to display all visual information, will there be some type of manual limit placed on the procedural generation to ensure that all assets will never be required for a single room? Well, that's kind of getting ahead again of where we are. But the simple answer to that is it depends on what our asset plan is. It depends whether our assets have a degradation path or not. Oh, end of questions. Right at the end of questions? How is that possible? That is just that is a good omen, people. Well, ladies and gentlemen, thank you very much for joining me for another episode of Handmade Hero. This was a pretty fun one. I'm kind of glad we have a little dude moving around now. That's a little bit satisfying. And it makes me want him to have a nice sort of feel as he moves and a nice animation as he moves around. And so I feel like that kind of answers my question of what we should do next. I think I definitely do want to go ahead and say, let's animate the guy next and make him have kind of a nice feel as you move him around. Because that'll basically let me start talking about the math and let us get into some kind of really interesting stuff. Yeah, I think that's what we want to do. So I think tomorrow what we'll do is we'll end off. I'll take a look at my sheet of stuff that we've postponed. Tomorrow will basically be our final cleanup day. We'll just go through everything, anything that we want done before then, and then let's just go ahead and say, unless there's some major turnaround over the weekend or something, let's just go ahead and say that Monday is going to be our day to start some serious math action, because that's going to power us up a lot, and we're going to need that power for all the stuff that we're going to want to do. So, please consider joining us for that for that episode, Monday, 8 p.m. PST. We will be back here. But if you would like to catch us tomorrow is the stream for our friends in Europe. Obviously on Fridays, we always go ahead and do a stream earlier in the morning so that people on other time zones can catch. So instead of 8 p.m., tomorrow's will be 9 a.m. Pacific Standard Time in the morning. So if you are interested in catching sort of the final step in our current series of Handmade Hero stuff before we start the math, please join us tomorrow at 9 a.m. Pacific Standard Time. I know it's a little bit early. I will be groggy, so will everyone else, but we'll get through it with a little bit of coffee almond milk, I suspect. And I would love to see you there. Again, if you are interested in following along at home and you have not done so, you can always pre-order the game, and that comes with the full source code. So you can always download every night after we finish programming. You can always download the latest source code and follow along at home. It also comes with the test assets that we're using here, so you can use those as well and see. You can kind of play around with them, just like we're doing. Similarly, if you want to support the video series, we have a Patreon. We also have a news or Patreon. I don't actually know how you pronounce that. I suppose Patreon. I'm not sure. But you can subscribe to that if you want to support the video series. And we have a news and forum site you can go to, which has a lot of great information on it. It's got the schedule for the week posted. It's got an episode guide with all the previous episodes, and people submit time-coded sort of jump lists, so you can jump around in them, which is kind of handy. There's a coding resources section, which has ports to other platforms. If you're trying to follow along on Linux or Mac, there's some great resources for you there. And of course, there is a code discussion forum if you want to ask questions. So please check it out if you're trying to learn from the stream. That's a great place to go. A lot of really helpful people up there, and people have done some really great stuff. So I highly recommend it. All right, thank you everyone for joining me, and I hope to see you tomorrow and Monday as well. So take it easy, everyone.